So today we will be discussing the next topic on carbonyl compounds, that is nucleophilic addition as well as nucleophilic addition and elimination reaction with ammonia derivatives with mechanism. So let us see this. So nucleophilic addition it is the addition of a nucleus liking species. So you understand what is nucleus liking. So some species which has electron rich or electron lone pairs or a negative charge, those species are nucleophiles, and of course they have like an excess of electrons apart from the number of electrons which is required for noble gas configuration, more than 8, you can say. So therefore these are excess, so therefore this can attack a carbocation. And here we have seen that in carbonyl compounds there is a bond, that is pi bond, between carbon and oxygen, and this pi bond can break easily to give oxygen a negative charge and accordingly positive charge on carbon. So a nucleophile, whenever it comes, an electron-rich species, whenever it comes near carbonyl compounds, definitely it has an ample opportunity to attack the carbocation and accordingly form a bond. This is what is an nucleophilic addition reaction, where an unsaturated compound, unsaturated means there should be a pi bond, and all finally converting all to sigma bonds. Okay, so therefore unsaturated to saturated. So this is what is nucleophilic addition. Also, this O minus can abstract a proton from the acid and accordingly form a saturated molecule. So this is what is nucleophilic addition. Now nucleophilic addition, when the nucleophile is a neutral species, say for example, here you can consider any nucleophile. So this is not the correct structure. You can take here something like ROH, okay, or ammonia, okay, all those where the nucleophile is the atom, central atom is having a lone pair, it can attack the carbocation. So therefore here we are having this should be something correction is required, and I will give you the corrected one. So here what you have is H is having bond with the nucleophile, now presently having a positive charge. So therefore this O minus will abstract this H as H plus, and accordingly you will get a compound, and this compound has a special feature. This carbon is having bonds with two electron rich species, oxygen as well as this particular atom which is electron rich species, and therefore one water molecule can leave. I will show you the mechanism right now. Apart from that, if you study the relative reactivity of carbonyl compounds, what you will see here is the carbonyl compound which is having lesser number of plus I effect, this will be less stable and accordingly it will be more reactive. Means the nucleophile which will come and attack the carbon, the positive charge will be more strong or focused, okay, it will be pinpointed. Whereas here the carbon with having the positive charge, this has been shaded, or a kind of covering has come because of the plus I effect groups. So therefore 2-degree carbocation is less reactive or more stable. Similar is aldehyde. Aldehyde is more reactive because it is having 1 plus I effect group, whereas ketone is less reactive, more stable because it is having 2 plus I effect groups. Okay. So let us see the examples how this addition is a HCN, how it is reacting. HCN is a nucleophile which is Cn minus. The minus charge is residing on carbon, and accordingly this carbon is able to attack the carbocation, forming a bond, carbon-carbon bond, and accordingly O minus will take this H plus, form HCN, accordingly form this compound. Okay. Now this one is next we have monohydric alcohol, means a primary alcohol, and monohydric means one OH group. So therefore it will also form and it will form a hemiacetal. This type of compounds are called hemiacetal, where you have one OH and one OR. Okay. Similarly, the reaction can be with the Grignard reagent, which you have already done in the last few classes in your campus classroom. Okay, so here it is a primary amine, how it is reacting. Now we are slowly proceeding towards addition, nucleophilic addition as well as elimination reaction. So here you can see the nucleophile is coming and attacking this one. Let us show you this one, this mechanism. So this will be an assignment. You please show the mechanism of this one, this reaction. Similarly, this will be an assignment. Similarly, there are several assignments here that I have shown here the mechanism of only one reaction. So this is attacking the nucleophile. The nucleophile gets a positive charge, the nitrogen here gets a positive charge, and accordingly this H will be abstracted by the proton, the oxygen O minus, and accordingly see here the carbon is bonded to two electron rich or electronegative atoms. So accordingly this becomes a kind of tug of war, both are pulling, and accordingly one has to leave. So here the OH can leave as OH as water. So this will be abstracting one proton from acid, and accordingly this will leave as water molecule, and as it leaves, the lone pair takes part in formation of the pi bond, and this nitrogen is getting a positive charge. This nitrogen is getting a positive charge, and this nitrogen afterwards the conjugate base of the acid will take this proton, and accordingly we will neutralize this nitrogen from this positive charge, and accordingly you are getting the imine. Okay, so therefore what you have, it is having an addition, and after the addition is done, then it is going for elimination. So it is an addition-elimination reaction. So accordingly you have to do here several assignments. This is also an assignment for you, this is also an assignment for you. So all this you have to do immediately after this class and show. Okay, anyway this study material you will be getting to show the mechanism and submit it at the earliest. Thank you so much.